Hey everybody, I hope that you are doing well. So this is our fourth lesson. We're doing order of operations. Now a few words about the last few assignments. Make sure that you are completing them. As I'm grading them, you should check your grade and click on the grade in Blackboard to see if I left you any comments. If you miss some, I tell you which ones you've missed. And I may give more guidance or may not, depending on how badly you missed it, or if I feel like you need more help. Okay? So, order of operations. So I know that everybody learned this in school, and the way we often learn it is they try to teach you this big thing. Some people remember it as "Please excuse my dear Aunt Sally," and I'm going to say, well, that's all fine and splendid. It's a bit misleading, and so we're going to go through and break it down as to why it's misleading. First off, P. You start with P and they tell you that stands for parentheses, right? They say this is parentheses. And that's misleading because there are other grouping symbols. And so we need to consider this to be all grouping symbols, or anything that groups operations together. For instance, it can be parentheses with some stuff in between them. It could be brackets. It could also be some more unseen ones. So for instance, this is a big deal. Please pay attention to this one. I do not see any grouping symbols here. But these have what's called implied grouping symbols. Implied. To imply something means we don't come right out and say it or show it to you, but it's understood to be there. The implied grouping symbols on a fraction are as if you have operations to do up top and on the bottom. Those are grouped. You need to do the operations up top and the operations on the bottom before you can try to simplify this fraction or divide. Other understood grouping symbols are things like absolute values. I would do what's in there before I did anything outside of it. Or square roots. Before I try to square root things, I need to do what's inside of there. So these are the grouping symbols. Everything inside of something, sometimes you don't even see the grouping symbol. So P really should probably be G for groupings. So that's the first way it's misleading. Okay, so next we hit E. Try to divide this so it won't get too messy. E, we're told, is exponents, right? So you have 2 to the 3rd power and you do the exponent before you would add to 3. That's correct. This also includes square roots and things, which kind of are included here. Either way, you do them before you go on to any of the other operations. So that's the simplest one, exponents. It's understood. And then this is where we get to a really confusing part. Multiplication, division, adding, and subtracting. And this is where we've been really misled. Okay? Let me give you an example. Let's see. 12 divided by 2 times 3. And so, how do we do this? Which thing comes first? And I'm going to go ahead and tell you that you look at this and you would be led to believe that multiplication comes first. And so you would do that first. But that would actually be wrong, because multiplication and division really happen at the same time. These are one thing. There's really only 4 steps to order of operations. There's grouping symbols, exponents, multiplications and divisions, as you see them from left to right, and addings and subtractions also are grouped as a single thing. So really there's only 4 pieces. So instead of P, please excuse my dear Aunt Sally, we should have groupings, exponents, multiplications and divisions are one, addings and subtractions are another. Why would these make sense to be grouped? I have told you when we learned division, division is just multiplying by the reciprocal. So really there's not even an operation for division. Really it's all multiplication. And how do we read left to right? So we got to do any divisions or multiplications we see from left to right. So for instance, if I were to do this problem, left to right, I see a division before the multiplication, but really these are the same level of importance. So we do whichever one we hit first. So 12 divided by 2 is 6. 6 times 3 is 18. Okay? Same thing for adding and subtracting. If I see 5 minus 2 plus 2, it is extremely important that you notice these are the same level of importance. I don't add before I subtract. I do whatever I see from left to right. So I would go 5 minus 2 is 3, and 3 plus 2 is 5. Okay? So that leads to some confusion with order of operations. Okay. Now, when doing all these order of operations, we're mentioning some things we have not dealt with. We have not dealt with exponents, and we have not dealt with absolute values or square roots and such. So, before we jump into bunches of examples of order of operations, let's talk about exponents. And more specifically, I want to jump into two examples, and compare them. Is there a difference in negative 3 squared versus parentheses negative 3, close parentheses squared? Is there a difference here? And the answer is yes, there's a very big difference. So the exponent, the 2, applies to what it's touching. Okay? So whatever it's touching is what it is applying to. So let's look right here at the first example. This 2 is touching the 3. Is it touching the negative? No, it's only touching the 3. So only the 3 is being squared, not the negative. Okay, let's go over here. This 2 is touching a parenthesis sign. So what is the 2 being applied to? The parentheses. Well, what is a parenthesis? This is a grouping symbol. So the 2 is being applied to this group. I can't just have half a parenthesis without grabbing the other half and everything inside it. So this 2 is being applied to this entire parenthesis grouping. Now, what is an exponent? What is an exponent? It's just how many times we're multiplying something by itself. So it just is a number of things multiplied. For instance, this 2 tells me that I'm going to multiply 3 by itself, and I'll have 2 of them. So it does not apply to the negative sign, but it does apply to the 3. So I will have 2 3s being multiplied. And this will result in negative 9. Over here, the 2 is touching the parentheses. So it's telling me that I have 2 groupings of parentheses. Well, what's inside the grouping of parentheses is negative 3. What's a negative times a negative? That's a pretty baby, a positive. 3 times 3 is 9. So notice the signs are different on these two things. Okay? Now on the test, they may ask you stuff like, hey, what's the base? What's the exponent? Things like that. The base is just asking my question as to what is being touched. What's being touched by the exponent? So up in the first example here on the left, the 2 is touching only a 3, right? It's not touching the negative sign. In the second example, the 2 is touching the grouping symbol and whatever is inside it. So the base here is 3, the base over here is negative 3. So the base is just a lazy way of asking, what is the exponent touching? Okay, they will ask you this on the test. You have to write the base out and then do the work. Okay? Now, one other thing is, what are absolute values? What is an absolute value? Absolute value. Let's talk a little bit about what an absolute value is. An absolute value actually is just a measure of distance from 0. Okay, it tells you how far away you are from 0. Now there's an important thing, because some people try to give you definitions of this, which suck. This is the textbook definition. The reason why absolute values, quote, make things positive is distance is always positive. So for instance, I don't care if you run 2 miles to your grandmother's house and 2 miles back. You ran a total of 4 miles, right? I don't care if you run it backwards. It's still 2 miles there and 2 miles back. You still ran 4 miles. Distance is always positive. We always measure it in positives. Okay? Displacement is something different. We won't even bother with that in this course. So for instance, you could also visually, once again, think of a number line. There's 0. If you happen to have -3, and I say, hey, what's the absolute value of -3? It's the distance from 0. How far away is -3 from 0? 1, 2, 3. Why? It's 3 away from 0. Likewise, if I ask you for the absolute value of +3, how far away is +3 from 0? 1, 2, 3. It is also 3 away from 0. So it always gives you a positive as long as there is nothing else happening on the outside. So inside, this will always come out positive before you do any other operations to it. So a few examples. Let's see, I could do things like, what's the absolute value of -10? And you should happily tell me +10. I could go a little bit trickier on you and tell you, hey, what's the negative absolute value of -10? And then I would want you to take this in steps. I'm going to leave the negative alone, and I'm going to do the absolute value of -10. What's the absolute value of -10? It is +10. So that's what this equaled. Now, this negative was outside the absolute value. So order of operations tells me I do what's inside the absolute value, and then I happen to have this negative floating there. So if there is a negative outside the absolute value, yes, I can get a negative answer. The absolute value part came out to +10, but the negative is tagging along for the ride. Let's see, how about one like this? 2 minus 7. Once again, let's do it in steps. What is 2 minus 7? Be very careful. 2 minus 7 is -5. What is the absolute value of -5? +5. Is there anything outside the absolute values? No, so 5 is our answer. Okay? No matter what I put inside there, if nothing's outside it, you're going to get a positive out. So now I think we're ready to do some more examples of order of operations. So let me give you some that confuse some people. So 6 minus 9 plus 5 minus 7 minus -12. All right, and we should run through our order of operations. So the first question is, do you see any grouping symbols? Some people may say, right here, I see parentheses. Is there any operation inside of there? No, just -12, so nothing to do there. Do you see any exponents? No. Do you see any multiplications? No. Do you see any divisions? I should say multiplications and divisions together. No. Everything is adding or subtracting. Remember, adding and subtracting have the same level of importance. So I'm going to do these as I see them from left to right, like we read. Now listen very carefully. On the test, you will be allowed a calculator. Yes, if you have a scientific calculator and you type this in exactly as you see it, you should get the correct answer. But you're going to turn your work in. To get credit, you must show your work. Must show work. Okay? To get credit, you must show your work. Now, showing your work's really easy. Getting the answer is really easy with the calculator, so when you combine those two together, you should easily get full credit. So I'm going to go left to right. Left, I first see the subtraction, 6 minus 9. So take your time doing 6 minus 9. I will be your calculator for you and tell you that is negative 3. And then I'm going to bring down everything else. Notice I have not messed with anything else. So then I can do my next step. Left to right, negative 3 plus 5, that is positive 2. Bring down everything else. Okay, then I hit 2 minus 7, that is negative 5. And then finally, I have negative 5 minus negative 12. Remember, we can think of this, if you have struggles with these, subtracting we can turn into adding the opposite. The opposite of negative 12 is positive 12. This is just negative 5 plus 12, which is just positive 7. All right. So there's how you will show your work. I will need to see this to get full credit. You could skip the step right here in black, but you need to have the red, the blue, and the green, the other red, and the final answer. Okay, you could type this all on your calculator, and it should give you 7. Okay. All right, let's go on to another example. Let's see. How about one like this? 12 minus 16 divided by 2 times 4. Once again, we need to run through our order of operations. Do you see parentheses? No. Do you see exponents? No. Do you see multiplications and divisions? Yes, I see multiplications and divisions right here. Remember, I'm going to work them left to right. So the 12 is going to be left alone for 1 step or 2 steps. I'm going to do the division first. Anytime there's a subtraction or a sign in front of the number, it belongs to that number. So we're going to think of this as like negative 16. Negative 16 divided by 2 is negative 8. Bring down anything we have not done. So we did the division first. Negative 16 divided by 2. Now we're still doing multiplications and divisions. So don't mess with the 12. Negative 8 times 4 is negative 32. Okay. Now I've done all the multiplications and divisions. I do not see any. Now we're just left with addings and subtractions. And I have a subtraction. 12 minus 32 is, I believe, negative 20. You can check me in a calculator. All right. So you must show your work to get credit on these. A few more examples. A few more, then we'll end. Maybe 3 or 4 more examples. Maybe 5. I don't know. You might see one like this on the test. So negative 8 times negative 3/4 minus 9 plus 2. I see a grouping symbol, but I can't do anything with this fraction. Okay, I don't have any exponents, so I move on to multiplications and divisions. Right here is a multiplication. If you wanted to do some scratch work, negative 8 times negative 3/4, this is actually not too bad because I can turn that into 8/1 and easily multiply fractions. A negative times a negative is a positive. Pretty baby. 8 times 4 is 24/4. That reduces. 24 divided by 4 is 6. So this whole piece right here spits out as a 6. Minus 9 plus 2. I do not see any more multiplications or divisions. So now we're on to adding or subtractions from left to right. 6 minus 9, that's what we shall do next. 6 minus 9 is negative 3. Bring down the plus 2. And finally, negative 3 plus 2 is negative 1. So order of operations, just moseying along. Make sure you're careful with it. What about one like this, where I have lots of grouping symbols? 2, bracket, 9 minus parenthesis 3 minus 7. So the order of operations tells us to go to grouping symbols first, and I see 2 sets of grouping symbols. What you do is you work inside out. So we're going to start with the deepest inside set of grouping symbols. So that means I am not messing with any of this stuff yet. I'm just doing 3 minus 7. 3 minus 7 happens to be -4. Okay? So I have taken care of this insidemost grouping symbol. Now I can do what is inside the square bracket grouping symbol. So we're still on the P, the grouping symbol part. We haven't even moved past the first step because we still have grouping symbols. So 9 minus a -4. Remember, this is like adding the opposite. So that's like 9 plus +4 or 13. Okay. We have finished grouping symbols. There is no exponent, so now we're on to multiplications and divisions. And this is understood to be a multiplication because there's no operation there with the grouping symbol separating these two things. So 2 times 13 is 26, and I'm finished. Okay. One or two more. How about one like this? People don't like these because they see fractions and they get a little nervous. But it's actually pretty simple. So first, we're going to do grouping symbols. Remember, when I have a big fraction, there are understood grouping symbols on the top and on the bottom. So I would like to work everything on the top and everything on the bottom before I try to mix them together. So looking at the top one, order of operations say I would multiply before I subtract. Does anybody happen to know 1/3 times 12? It's actually pretty easy to do if you put a 1 on the bottom. This just ends up being 12 divided by 3. 12 divided by 3 is 4. So I could do that. So we'll have 4 minus 2 up top. And I can do the same step in the bottom here. I can work them both kind of at the same time. 1/4 times 8. And I can do the same thing, put a 1 on the bottom. 8 over 4, 8 divided by 4 is 2. And then 4 minus 2 is 2. And 7 plus 2 is 9. Fraction does not reduce, so we're done. Okay. Look at another example here. -11 plus 5 inside parentheses. 3 squared inside parentheses. All over 6. Could I do this? So you say order of operations parentheses. So I could do both of these parentheses, or grouping symbols. -11 plus 5 is -6. 3 squared. Remember, 3 squared means I have 2 3's being multiplied. So 3 times 3 is 9. And on the bottom I have 6. Okay. And then I can use my calculator to carefully multiply. A negative times a positive is an ugly baby, and 6 times 9 is -54 over 6. And then carefully use your calculator to divide. And -54 divided by 6 is -9. Or you could have noticed that now I'm down to just a multiplication and a division. I could cancel and just get -9. The negative, don't lose the negative. Either way is fine. You could do the green or you could jump from the red to the answer. I'm perfectly okay. All right. Last example would look something like this. This is called a third root. We'll talk more about roots and stuff later in the course. For some reason, they like to throw these on the test, even though they're not material that we're supposed to cover yet. But this is called a third root. If there's no number there, it's understood to be a squared root. What you're looking for is a number that multiplies by itself 3 times to give you 64. So you could guess and check what number would multiply by itself 3 times to give you 64. It's the opposite of an exponent. So you could try, okay, well, 2 times 2 times 2, that's 8. That's not going to work. 3 times 3 times 3, whew, that's 27. You could just use your calculator. That's not going to work. What number multiplied by itself with 3 of them, the reason I'm doing 3 is because of the third root, it's going to give me 64. 4 times 4 is 16 times 4. Oh, wait. I believe that's 64. Isn't it? Awesome. So we did, the order of operations tells us to do this grouping symbol. So the square root of 64, not the square root, the third root is 4. And on the bottom I have 4 plus 8 times 3. So let's finish the bottom up. 8 times 3, we can do that. That's 24. 4 plus 24 is 28. Now, does our fraction happen to reduce? Is there a number that divides evenly into the top and into the bottom? Yeah, actually 4 will divide evenly into both of these. Okay, because 4 divided by 4, that gives us a 1 on top. And 28 divided by 4 is a 7. It gives us a 7 on the bottom. So 1/7. All right. Your calculator will easily do a third root for you. I don't have an emulator on my laptop here. So you can Google how to do a third root in your calculator, and there will be lots of YouTube videos showing you how to do that. I advise you to do that just so you don't have to try to do this on the test. You can just type in, hey, what's the third root of 64? Oh, it's 4. Now I can continue the problem. Awesome. Remember to do your worksheet and your My Math app. I hope you have a wonderful day.